Hi, it's Jan Beta, and as you can see I'm back here with my pretty much taken to bits Amiga 2000. It has developed a slight problem lately, so let me show you. So let me just boot up something here. Well, most of it works, and I didn't notice the fault I'm about to show you until very recently. Yeah. It's a bit of a bummer because I don't know when it occurred really, because I didn't. So listen. Can't hear it very well this part, but so the sound is distorted. I don't know if you can hear it very much, but there is sound, it's all there, both channels and stuff, but they are both distorted and they are pretty silent. So that's what my Amiga 2000 sounds like recently. I don't know since when really, because I didn't have the sound connected even for the last couple of videos, and I didn't play much games on this actually. I fiddled around with Workbench and stuff like that and didn't pay attention at all to the sound. So it might be that the fault occurred just after recapping or things like that, or after recapping the power supply. I don't really know. So let's investigate. So first thing I did off camera to check is to replace the Paula chip, which is the chip responsible for the generating the sound, with a known good one. And yeah, it's not changing anything. It's just really pretty much the same. And the one that was in here worked fine in an Amiga 500 board I quickly tested it in. So this Paula chip luckily is fine. There's some peculiar things about the audio circuitry in Amigas in general that I want to point out. And I have to thank Gadget UK 164 for this because he pointed that out. It's the first time I realized that there is some issues with the sound output. So first thing I want to do is to take the PCB out. And speaking of PCBs,
let me thank my sponsor PCBWay who made this video possible, and they offer quality PCB manufacturing. At the moment they offer PCB assembly. That means you can have the components put on the board for $30 for 20 boards, which is quite a bargain.
So got the board out, and I've focused a bit on the audio circuitry. These are the red one and the white one are the right and the left channel. Audio out, which are coupled with these two capacitors, which are 22 microfarad 16 volts capacitors. Originally they are polarized, and I replaced them with polarized ones, although in this kind of circuit with a differential amplifier that has like positive and negative waves going through it, you don't want polarized caps in here. You really want bipolar caps, which I am going to insert eventually. I don't have any with the right capacitance at the moment, but I am going to replace these with 22 microfarad bipolar caps, probably Nichicon Muse or something like that, because I want this to be an audiophile machine again, given that I can fix it. Maybe that's the fix. The op amp is an LF347 originally, I believe. In this one, it's a TL084, TL084. So that's the same. It's pin compatible with the LF347 that you find in most early Amigas. The circuitry interestingly changed very little across Amiga models. Even later Amiga models have the misconception of these polarized capacitors in there, which are not a big deal. The sound quality is amazing still, but really, if you're building such a circuit, you have to use bipolar caps. So I'm going to link in below a little article that I found about that. Yeah, I probably am going to do that sometime in the future. But now let's test the audio circuitry, really. So powering an Amiga 2000 board without the case is a bit peculiar because you have to. This cable from the power supply is pretty short, so you have to put it someplace, I guess. I will see how this is going to work out, but it's connected now. I have the monitor connected and I have the audio connected, so yeah, this is probably going to do as a test setup. Don't recommend doing this. Probably you could just make like an extension cable yourself or something like that, but it just fits, so I'm gonna go with this setup. Obviously it starts up with the 3.1.4 startup screen because I don't have any hard disk connected or anything. I have the disk drive connected for using test software or reinserting Turrican 2. So yeah, let's get some voltages first. So I got myself a data sheet from the LF147, which is basically the same. It's a quadruple op amp with inverting and non-inverting inputs, 4 inputs. We only need 2 because it's only stereo. It has 1 voltage plus, 1 voltage minus input, so it needs, in this case, plus 12 and minus 12 volts on pin 4 and pin 11 respectively. So let's see if we can find that while the machine is running. So let's find a ground somewhere. So this should be positive 12 volts. Oops. Which it nearly is. And this should be negative 12 volts. Oh, which it isn't. Okay. This isn't negative 12 volts at all. It's a matter of the voltages from the power supply, I guess. Okay, let's see. The blue wires on the power supply should be ground, which they are. So the blue wires are ground, actually. Let's turn this on again and measure. Okay, so this is ground, and measure the voltages. So the yellow one should be 5 volts, I guess, which it is. The orange one, I have no idea. This is our plus 12. The red one is our minus 12. Okay. This is another 5 volts. White. Another minus 5 volts. And the brown one is, I guess it's the tick signal, which is like a timing signal, which would result in something like this. So, yeah, this seems to be, the power supply seems to be fine. So, 11 volts, minus 12. So the 12 volt is a tiny bit low, but that's gonna be, it should be alright, I guess. Minus 12 is here. So why isn't that on the op amp? By the way, if you have distorted audio on an Amiga, this is a common problem. Usually it's the power supply that doesn't provide the minus 12 volts, or has like a wonky 12, minus 12 or 12 volt supply. Whereas the minus 12 is, I think, is only used for the sound. So if that's broken, everything else works fine. except for the sound. So that's one thing to look for. So yeah, why isn't this working correctly on this one? That's interesting. Maybe we got a wonky capacitor there or something. So after the power supply, there's after the connector, there's some additional smoothing capacitors, and the -12 goes to this smoothing capacitor that obviously has the negative to this direction because it's connected to the negative here, yeah, which it is, and this should be for the -5, should be here, yeah. This is the other capacitor that's connected the other way around. Yeah, I kind of let's measure if that if the voltage arrives on the other side of the capacitor. Should be measuring ground against this. And it's -12, yeah. You couldn't see it, but it's the same voltage. So why doesn't it arrive at our chip? So, got some schematics out for the power supply. This is the -12. I don't know if you can see it correctly. Let's zoom in a bit. -12. This is the power connector on this side here. And the -12 just goes over here. Decoupling caps. And it goes through a diode for the -12 volt user, whatever that is. We are looking for the -12 volts because that is what is used in our audio circuitry here. This is our audio circuit. -12 goes through a little resistor directly, more or less directly into the U204, which is our LF347 op amp. So that is our negative voltage rail, which apparently just comes from the power connector. Goes through some I think the diode is just for reverse polarity protection basically. And yeah, just there's some decoupling caps that could be wrong. C223 maybe. Don't really know. So let's check some diodes, I guess. This is the D401 that is kind of parallel to the that looks good. It's a 4001 1N4001 standard diode. And this is the other one, D400. Yeah, these seem to be alright. Capacitors seems to be alright because we get the correct voltage after the capacitor. I should test the capacitor there. So testing the decoupling cap right after the power connector. Should be this one here. And that's very much fine. So actually it's a 47 microfarad cap supposedly. And the others that are the same capacitance measure about 47. Now that's interesting. So maybe got a bad capacitor there. Let's desolder it and find out this one here. It's perfectly okay. So the other place the minus 12 volts are used is the Zorro slots here. Some Zorro expansion cards use minus 12. Yeah, let's see. And there are some vias on top here where you can. It's nearly impossible to show you the multimeter and the vias at the same time. So, yeah, it's there. There's our minus 12, there's our plus 12. Absolutely fine, and this should be like 5, I think. Yeah. Yeah, so, wow! The minus 12 seems to be everywhere except for at the little op-amp chip, which leads me to believe that maybe the op-amp chip is broken. So the little op-amp doesn't get hot or anything, so it might still be that it's shorted in some way or the other, so I don't really know. Maybe I should just remove it and see if the voltage gets to the pin there. It's still absolutely wrong. Might be that the positive input voltage comes through there. I think I want to desolder this little IC and see if that helps the voltage reach the normal level, and that would be a clear indication of this chip being broken and shorted in some way. I usually mark chips that I want to desolder, because if you're looking at the back side of the board or the bottom side, you can. It's easy to get things confused. Not that it ever happened to me. Yeah, it did, obviously, but yeah, I'm just making like a little mark there where I want to desolder, so I don't accidentally desolder the wrong chip. And for easier desoldering, I'm applying some flux. I'm using this stuff, which I have. There's other better flux, I guess. This is a liquid flux. Can also use a paste or something like that. This makes it easier to desolder, actually. And I'm, of course, as you have probably seen in other videos, I'm using my desoldering station, which served me well for a couple of years now. So, and I see which pins are loose already by wiggling them around a bit. This was still stuck for a bit. Most of them are loose now. That came out pretty easily. Cleaning the board a bit, and now we're going to reconnect power and see if our voltage gets through normally. Or otherwise there's probably some other component that's broken. Okay, so this is 11 and this is 0.8 something. Wow, okay. So there's no voltage basically coming through. That's interesting. Why is that? Let's check the path. So according to the schematics, the minus 12 should also be present on the resistor R208, which is this one here. And that's the same as... Okay. That's very interesting. So where does it come from? Maybe we should see on the other side of the board and observe. So because in all other parts where there's -12, we got perfect -12. So something is pulling it down on this side of the board, or it's not making it across to the other side of the board. So basically it seems like the -12 doesn't make it through to this side of the board. This side, everything seems to be hunky-dory, and we have -12 where it belongs, namely the Zorro ports and Zorro slots, and there's nothing wrong with the power inlet here. We get it on the -12 and the -12 user, which is protected by this 4001 diode. So it should be present here, which it isn't. Maybe we should just check if there's a power line going over there some way and see if there's a break in there. Ah, this is the resistor 208, it seems, and this is another one that's also labeled 208. Okay, that's interesting. Okay, this is impossible to see, but there's a resistor labeled 208 as well. Let's see if that has -12. Yes, that has -12. Okay, that has -12 on both sides. So that's where our -12 comes from. Okay, let me try and show this. There's R208. And this is what I thought was R208, which also seems like it's 208. It might be, it's 206 probably. 208 is there, and we have -12 here, and we have -12 here. Let's see where it goes from there. It seems it's going to this capacitor here. So we are at 211. It should go, yes, it's going through to this capacitor. And then it should go further to, let's see where that goes. Aha! I think we have a broken trace there. Okay, so I think I found a broken trace. I don't know if I can show this. This is where our -12 should be. And then it goes up here, here to this one. There's a contact. Then we go up here where there is contact. We go up here where there's contact. And then we go to our capacitor. And there's no contact between this and this. So we have to put a little watch wire in, I guess. Let's reassure us again. So this goes here, this goes here, this goes here, and this goes here. Usually, but it doesn't. Okay. I think it might even be enough if I just scrape away some of the solder mask and bridge the pin here to the copper. I'm going to try that. Okay, let's see. Connection now. Yep. Yeah, we have a connection now. That might have just fixed that. I think we should put back in our op amp. Let's see if that fixed the problem. So here's what I did. This connection from here to here, which I marked with the arrows there, was broken, and I just bridged. I think it was just scraped away some of the solder mask and connected the solder blob to the trace, which should fix our problem. And now we have a connection to the chip again. It should deliver 12 volts to our chip. Nice. Probably that is what the problem was. So I didn't have a 14-pin socket, so I made one by clipping the end of a 16-pin socket, I believe. So let's check if the voltage gets through now. So this should be -12 now. Which it is! Woohoo! So this is probably fixed. Let's reinsert the little op amp and see if the sound is working again. So, connected my speakers, I have my Turrican 2 disc in the drive that's top down. Hopefully it's going to work anyway. Connected the drive, connected the sound, connected the monitor. Let's see what it does. Maybe it works again. Hopefully. Hopefully the drive works this way around. I think it should. Yes! Yes! It is fixed! It was just one missing connection. Who would have thought that? But luckily I knew about the -12 and +12 from some other video or, I don't know, some blog post. So yeah, this concludes this video, I guess. We fixed the fault and it sounds pristine again. Hope this was informative. I screwed up while replacing the capacitors, probably, but this stuff happens and it's good to know you can always try to troubleshoot this stuff. Yeah, this time it was a success. I'm pretty glad it turned out this way and wasn't something more serious. Yeah, so much for now. Thanks for watching. Especially I want to thank my Patreon supporters that are going to be listed in the credits screen kind of thing. And yeah, thanks to all of you. Stay tuned for more and see you all soon. I'm Beta. Bye.